In this video, we're going to build on this 5-column left to right, top to bottom format with a couple different approaches of solving the same problem over and over and over. Before we do that, though, I'm going to add just a little bit of formatting to make this pop a little bit in clarity, where I could just simply add a little bit of color to make the formatting pop off the screen a little bit better. So it helps to separate the inputs, the intermediate calculations and outputs. Also, just by way of review, I've pasted a little graphic here. This time-tested recommendation for problem solving essentially flows like this. To place the framework in the 5 columns, to fill in the inputs and identify the outputs. Then you go back and identify the intermediate calculations that you need. Then start putting numbers and formulas in. As you're working on the intermediate calculations, you may find that you put them in the wrong order. If that's the case, you simply cut, paste, or insert rows and fix it so that it actually flows top to bottom. Then echo the formulas in column E. We'll show in a future video adding comments and text boxes and other things. But that's just a review of how we got to this point already. So the simplest way to solve another problem, essentially side-by-side scenarios, is simply right-click on that C of column C and copy. Click right-click right back on it, insert copied cells. And then now I have side-by-side scenarios where maybe this cylinder is a bore of 75 and a rod of 25. This one is a bore of 100 and a rod of 25. And I instantly get a different problem solved without eliminating the first case. I could do that again, could keep doing it over and over, inserting copied cells. And then maybe I have a smaller one, 50, 75, and 100, and the forces that those cylinders would generate. So this is side-by-side columns, but I only did the math one time, and I'm trying to replicate that in multiple instances. Another good feature to do is to rename this sheet. Instead of sheet 1, actually name it to be something that's useful, like cylinder force. All right, so that's the side-by-side columns that allows you to solve multiple scenarios. In this case, it's very compact and the number of intermediate calculations is low, so it's not too cluttered. But if you can imagine a spreadsheet that's kind of long, maybe 2 or 3 pages tall in this structure, then that becomes a little cluttering to just show all of the intermediate calculations. So I'd like to introduce you to something in the data ribbon called What If Analysis Data Table. That's not a table of data, but it is a data table. Look at the fine print. See the results of multiple inputs at the same time. So we're going to use that feature, but in order to do it, it first helps to fully label the caption. So I'm going to pause my recording and let magically appear a caption for a data table. I believe the best way to do a data table is to fully lay out the caption and then fill in the data table. So here we have it, a one-dimensional data table of cylinder force in kilonewtons with the varied cap end pressure. Now, when we vary the cap end pressure, in this case there are 3 other variables and they're all fixed, so I identified what those fixed values are. Now a data table has a very particular structure. So I'm going to put the cap end pressure as varied from 15 to 20, 25, and 30 megapascals. The output is the external force, and I'm going to use the kilonewton output. And so I'm going to put some color here just to make notes of things. I'm going to highlight this cell which happens to be the setup cell for the data table. In this one-dimensional table, this is the varied cap end pressure. I want to report the external force in each case. So in this setup cell, which is essentially over 1 and up 1 from the first set of inputs, it points to where does the answer come from. So I'm going to put the equal sign, and since I'm doing the 75 millimeter bore, 25 millimeter rod, that is my column D. So I'm basing this table on column D, and the answer comes from D15. Now I can highlight not this, because it includes the caption and some external other text. It's not just this because it doesn't include my input variable. So the range to highlight is exactly that. Data, what if analysis, data table. And in this case, I have a column of inputs. So there is no row input cell. That dialog box wants something, but I'm going to leave it blank. The column input cell, I explain it this way. Here's a column of inputs. It is P1, pressure on the left end of that cylinder. I want it to use 15, 20, 25, and 30. Where should those values go? Essentially one at a time. P1 goes into row 5. Well, it's not C5 because I'm getting the answer from D15. So it's D5. And I simply hit OK. And I'll fix the digits here. And so now I've run the scenario. It's like changing this pressure 1, 4 different values, but I have a very compact little table here. That's a one-dimensional data table. Let's now do a two-dimensional data table where we're going to vary 2 things at once and see what the output is. Let me pause and generate the caption first. So for this case, we're going to generate the two-dimensional data table of cylinder force, which will be kilonewtons, with the varied bore and rod diameters. Since there were 4 inputs, the other 2 are fixed, so the caption captures the fact that the supply pressure is 20 megapascals and the return line is 2 megapascals. All right, so let's set up this two-dimensional data table. One of the variables is the bore, or the bore diameter. And the structure of this has to be exactly so, but I'm going to make it range from 65, 75, 85. We'll just go with 65 to 120 as the bore. And then we're going to have the rod diameter, also in millimeters. And let's let it go from 20, 25, 30, 35, and 40. So here's my two-dimensional data table. In this case, the setup cell is the corner cell, and it points to where does the answer come from. Since all of these scenarios up here had a 20 megapascal supply and a 2 megapascal return line, I could base this data table here, the second one, on any column, C, D, or E. So I'm going to just choose to base it on column C. And since that corner setup cell points to where the answer comes from, the answer comes from C15. So now I highlight the data table and make it happen. First, what you don't do. That is not what I highlight because it includes my column and row labels. This I don't highlight because it includes the caption of the whole table. This is not correct because it doesn't include the rod diameters. This doesn't work because it doesn't include the bore diameter. So the right part to highlight is from that setup cell through all of the input variables, or the independent variables in this case. So back to data, what if analysis, data table. In this case, we actually do have a row input cell. Rod diameter should go where? It is a row of inputs, 20, 25, 30. It should go to the diameter of the rod, and I'm going to base this table, since the answer came from C15, the row input cell is C4. The column input cell, my column of inputs, is the bore, and the bore, or the diameter of the cylinder, should go into C3. Click OK, and what I've done is quickly solve lots of combinations of bore and rod diameter scenarios in a very compact table, which sets me up nicely if it were some different kind of a problem and I wanted to now do a scatter plot. It'd be very easy to generate the chart from this data. So just recapping, what did we do? We started with a simple scenario of a column of calculations. We duplicated to generate 3 side-by-side columns. And then we also duplicated by generating a one-dimensional data table, which would be one output with one variable changing, and a two-dimensional data table, which has one output, but with 2 things changing. Now, the last thing I need to demonstrate here is that once you have a data table, you can't delete part of it. So if you found you made an error, you have to delete all of the cells that have this quirky little formula that looks like a bracket equal table C4, C3, parenthesis, bracket. If I made an error, I will actually have to delete all of those and start over, because you can't delete part of a data table. Again, I'm Dennis Buckmaster, professor in Ag and Biological Engineering at Purdue University. I hope this structure of problem solving becomes one of your mathematical habits.